to some of the things we're quizzing over. Okay? So let's get ourselves in a pre-calculus mindset. This kind of mindset.
Say it's a joke. Say you're lying.
All right. So now, who are we missing back there? Somebody. Liam, oh yeah. Is that it? Okay. All right, so we're in our notes, page 29, number 4. Given that two-thirds is a 0 of this, okay, let's find the other ones. Well, the first thing you're always going to do if someone gives you a 0, you are going to divide it out, right? We're going to get rid of it. Get out of the problem. So here we go. 2/3 times 3 is 2. 2/3 times 0 is 0. 2/3 times 6, 4. Well, this is working out great. 2/3 times 0. 2/3 times negative 24. Negative 16. There we go. Kids, if you don't get a 0 there, then I lied to you, right? I said 2/3 was a 0. I mean, yeah, 2/3 was a 0. You better get a 0 down there. Okay, so what's left? 3x to the 4th plus 6x squared minus 24. Would you agree with me that that's not quadratic? Yeah. But would you agree that it's in quadratic form? Yeah. In other words, think about what a quadratic looks like. This power is half of this one, right? That term is just a constant. So if you look at this, is the middle power half of the first power, and the last term is just a constant. So this can be treated like a quadratic. If you choose to factor it, now I don't know that it factors. I'm going to take a look at it and see. Oh, I think it does factor. If I choose to factor it, then instead of having x in the front of my parentheses, I will have x squared. And then I need a 4, 4 and a 2, is that right? So in other words, I'm treating it exactly as though it were this. That's its corresponding quadratic. Now, what if it didn't factor, or if I couldn't factor, or didn't want to factor it? Could I use the quadratic formula? Yes. If it's in quadratic form, if the equation looks like this, you can use the quadratic formula, but you're not solving for x equals, you're solving for x squared equals. So if you did the quadratic formula, you would get x squared equals something, and x squared equals the other thing, and then you would have to square root those, which is what I'm going to have to do, because this says x squared equals 2, or x squared equals negative 4.
Times 3.
Right? So when I square root those, I'm going to get my other answers, which are what?
On top of all this.
So this one's going to give me plus or minus 2i. This one's going to give me plus or minus square root of 2. And then we already knew the 2/3. So it says find the others. There are the other 4 roots. Right? So sometimes life is just awesome. And you get things like this that make it so much easier if you recognize its quadratic form. All right, number 5. Find all the zeros.
Wait, this is one.
Yep.
So when you factor out that 3, when you're finding the zeros, is the 3 just irrelevant?
Irrelevant because it doesn't have an X attached to it.
Okay.
If it has an X attached to it, but aren't I allowed to divide everything by 3?
Yeah.
That doesn't impact anything, does it? Now, if it has an X, then it does, then it's a root. But if there's no X, then it's 0. No X intercept. All right. Next problem, looks like a big one. We gotta find all the zeros, we don't have any hints given. So what are we gonna do? Yep, kids, this could be a quiz question. This exact thing, there's nothing different about this problem than the other ones we've talked about. So, I may not say, it may just say exactly what it says. So then you gotta think about what you're gonna do to help you. So somebody said PRRs. Okay, PRRs are meant to help. So they would be factors of 2 over factors of 3. So if I am guessing numbers, I'm gonna guess 2 and 1, 2/3 and 1/3, plus or minus all those. All right, so anybody got a feeling for that? 1/3. What did someone say, -2? All right, I heard somebody say -2, let's give it a shot. I hope whoever said that's right. All right, here we go. I gotta try something, so I guess it really doesn't matter. Oh, whoever said it was right on, because -2, if I did my math right, divides in evenly. So I'm finding all the roots, I'm gonna keep track of these. One of them is -2. Would you agree with that?
Also, 1/3 also works.
1/3, she says 1/3 works. Now, don't go back to the if you've already divided 1 out, don't go back to the original and put in 1/3. Use your depressed polynomial. Yep, there it is. So that is 1/3. Now, we definitely had some help there from the audience, right? If you're on your own, this isn't a group quiz, so if you're on your own, you're going to guess a number. It's either gonna work or not. If it works, great, guess another one. If it doesn't work, then just keep guessing until from this pile. That's a pretty small pile. Until you get it. Now, what are we left with here? 3x squared plus 3x plus 3. And the guessing is over because this is quadratic. And we don't guess with quadratics. That would waste our time. We just jump in and either factor it or use the quadratic formula. Now, just talked about with Lucy, I can get rid of those 3. You don't have to, but you might as well, because at some point you're gonna have to cancel them out. So I'm just gonna divide them right out of the problem or factor them out if you prefer. So what does that equal? Oops, it's gonna be imaginary, isn't it? -1 plus or minus I√3. So the directions say find all of the roots. Would everybody agree that I got them all? Those 2 and these 2?
Yeah.
Adds up to 4. Oliver?
What if we use the PRRs and none of them work?
Well, then we either have to approximate the roots, which is very time consuming, or we go to our calculator.
Yeah.
And if we have time, we can look at something like that. But right now, on this quiz, some PRR is gonna work, because this is a no calculator quiz. But I don't have a calculator. So Peter's devastated. All right, so now we go to number 6. Same directions. Solve. couple more to go after this one, so here's our thing. And we have to find all the zeros. I'm kind of an advantage because I have to write the problem down, and as I'm writing, I'm thinking about, does it group? Because if it groups, that's always the fastest way to do the problem. I don't think this one does though. Would you agree?
Yeah.
Okay, so we gotta start figuring out something that's going to work. And our PRRs this time are still factors of 2 over factors of 3.
Or would it be factors of 3 over
Factors of 2, it's 3 over 2. Thank you very much. All right, so 3 and 1 over 2 and 1. 1 does, oh my gosh. You people are living right. Or you have the nicest teacher in the world. There it is, right? So, I'm finding all the roots. One of them's 1. Two x squared plus x plus 3. No factor in there, so this is just like the last one. I got -1 plus or minus I root 23 over 4. Did I make any other mistakes there? Is that right?
I got that.
Know what you got? Good deal. Remember, as you are thinking about numbers to guess, to divide out, remember, you can also, to see if they work, division is great. You can also plug the number in and see if it equals 0. So 1s and -1s are easy kind of do in your head. So if you plug a 1 in here, you have 2 minus 1 plus 2 minus 3. So definitely that's. All right, review, recap, here we go. That's why I wanted to start here. How do we know from the start that problem number 5 has at least 2 real roots? So how do we know from the start that problem number 5, which is this one, how do we know without doing anything? Now we solved it, but how can I kind of look at it and know that it has at least 2 real roots? Maren?
The degree is 4, so that means it can have 4 or 2, like real roots. So that's why it's at least 9.
Well,
Or no, sorry. It has 4 solutions, but,
yes.
and it will have.
But in those 4 solutions, would it be possible for all 4 to be imaginary? Now, I'm not saying in this problem, but could you have a 4-3 polynomial and have 4 imaginary roots? Yes, you can't have 3, but you could have 4. So you kind of are on the right track. Hey, take a look at this. How many sign changes do you see? 1. Now, what does that mean? There is a positive real root, right? Now, can there be just 1 in this problem? No, because if there were only 1, there would have to be 3 imaginary, and is that possible? No. So the fact that you can eyeball this and see that there is for sure 1 positive root, that means automatically there has to be a -1. Now you could do Descartes' rule of signs and find that out, but you don't need to, because you can't have 3 imaginary. So the minute you find 1 real, you know there's got to be at least 1 more, right? At least 1 more.
What about negative reals? So how would you know the rest of them would be imaginary?
There can't be 3 imaginaries, Marin.
No, I meant like, how do
Stop.
you?
stop. How many roots does this problem have? 4. One of them is positive real.
Yeah.
Right? So doesn't there have to be at least one negative real? Because there can't be 3 imaginaries, right? Now, again, if you want to go through and do Descartes' rule of signs, you totally can, but you don't have to. All right, a long division problem. Here we go. We're going to do a long division problem.
Oh. Test for a,
How do I know that this is going to be a long division problem? What I'm dividing by, right, is not a linear binomial, right? What I'm dividing by is this quadratic trinomial.
and then you have to find it for the -1 thing.
All right, here we go. What do I have to take times x squared to get 3x to the 4th?
Could you factor it?
3x squared. So 3x squared times x squared. 3x squared times x. And 3x squared times -2. All right, everybody with me still so far? Lucy?
Could you factor the divisor or no? What you're, like the x squared.
Okay, so what Lucy's question is that happens to factor. The problem's gonna be, you could then, if we knew this was a 0, you could factor and divide each of the linear factors individually.
Yeah.
But I don't think this is a factor, so that won't work.
So it has to be a factor.
Yeah, in order to break it up, yeah. Because you have to end up with a remainder of 0. Otherwise, what are you gonna do with that remainder? I mean, if you divide in the x plus 2 or whatever, what are you gonna do with that remainder, right? Okay, I don't know whether it is or not, Lucy, I'm guessing it's not. It's not promising, I'll leave it to there, but let's see. All right, so now I subtract, right? Besides, I want you to practice long division, because sometimes it's necessary. So what do I have here? When I subtract, I get -x cubed,
Plus sauce.
11x squared, and then I'll bring down my -8x. Start all over again. What do I need up top to get this? -x. So -x cubed, -x squared, and +2x. So I got 12x squared minus 10x plus 3. So now what do I need up top? Last one.
12.
Plus 12. So 12x squared plus 12x minus 24. Yeah, we don't have a factor, do we? So I end up with -22x plus 27. Is that what you got? So what do you put in the quotient blank? The quotient blank is right up there. So the quotient is 3x squared minus x plus 12. And then the remainder is right here.
Yeah.
Now,
Do you divide it?
technically, that's over that. I don't really care if you put it over that or not. Because most of our work here is not about remainders, it's about finding factors. We did not find one, so we really don't care about this one. Okay? One more. Divide again, but this time, can we use synthetic division?
Yep.
Yes, but what do we have to be careful of?
Missing
I'm missing an x to the 4th. I'm missing an x squared. And that's it. You will not get the right answer, guys, if you don't fill those zeros in, so make sure you do. And then we have a 2 in the box. So here we go. I hear someone talking. I have a mistake up here? Oh, good. These numbers are getting quite large. Lewis, have you done this?
Yeah.
Is that what you got?
Yeah.
Okay, good. So Lewis says I'm right, so I'm gonna go with it.
Wait,
What is my quotient? Emma?
Wait, after the -4, wouldn't it? Oh, that's I know matter at the
Okay, what's my quotient then?
5x.
5x to the 5th plus 6x to the 4th, 12x cubed, 25x squared, 50x, and 92. And my remainder is 185. I don't care if you just write 185 or you can put 185 over x minus 2. On a totally unrelated note, what do you know? Take a look at this string of numbers there. What do you know about 2? It's definitely an upper bound of this mess. Okay? Now, so that takes care of 2, 5, so that homework will be due on Tuesday, I guess. All right, so here's what we need you to do. We're gonna take our quiz. This probably isn't gonna take the rest of the period. If you finish before, time is up, I want you to get your notes back out. I want you to read this introduction to 2.6, stuff I just copied and pasted out of your textbook. And then I want you to try these 2 problems. Mr. Miller was here and assured me that you have done graphing rational functions before. So you are going to take your quiz, put it in the tray, get your notes out, and then read this stuff as a refresher, and then try these first 2 problems on your own. Got it? Huh? The writers are back there in a box.